Hello, today we're going to be talking about the rate of change and slope. And your learning target is I can find the slope of a line. So when I am talking about slope, picture just a hill that you are maybe riding a skateboard down, or if you're rolling down a hill, a grassy hill or something like that. And remember that it all depends on the slope of that hill. That's going to tell how fast you move down, or maybe if it's an uphill, if you start here and you're hoping to roll up, that's not going to work because it's going up. So that's basically the concept of slope, but we're going to talk about it more so with graphing and lines, but we'll get into that in a little bit. Just keep that in mind when I'm saying slope. That's basically what I mean. All right, so before we begin that, let me just show you the rate of change. And the definition of a rate of change is the ratio. I'm going to write it out here. Okay, I typed it for you, so that might be a little easier to read. And it is the ratio of the amount of change in the output, or the y, to the amount of change in the input, or your x's. And we're going to do an example of this right now so you can kind of see what I'm talking about. So we're looking for the rate of change, the rate of, ooh, that's a silly O, rate of change. And we need to find the difference in the output over the difference in the input. Okay, so here is a chart from a girl who mowed lawns, and she earned $15 and mowed, in day one she earned $15 and mowed one lawn, or mowed someone's grass. And then on day two she earned $45 and she mowed three lawns. Day three she earned 90 and she mowed six, and so on and so forth. So we need to find the rate of change, and it's a ratio, so we know our final answer is going to be written in a fraction form. That's why I'm drawing my fraction bar now. And then I went ahead and drew that x is going to be my input and y is my output. So when I have an input, I'm putting something in to get this. So I'm putting 1 in and I got 15. I put 3 in and I got 45. So it's the amount of change in the output, the y over x is how I'm going to write this. And we're used to seeing it that way, so this won't be very different. So it's the rate of change. Well, the rate of change always has to do something with subtraction. So I'm going to write that over here so you don't forget. It has something to do with subtraction. And I already decided that I'm going to use day 2 and day 3 to compare. So I need to find the rate of change in my y's. So I need to do 90, take away 45, because I already decided that these are my y's. This is my output, and I'm doing 90 take away 45 so I can stay in positive numbers. I'm going to keep my division bar, my fraction bar, and then I need to do the rate of change, or the difference of my x's. So 6 take away 3. And then I just solve. 90 take away 45. I'm going to solve it up here. 90 take away 45 is 45. And 6 take away 3 is 3. So 45 over 3 reduces to 15 over 1, or just 15. So my rate of change for this problem is 15. Okay, and you probably could have looked at these ratios here and you might have seen that it was going to be 15, but in the future it's not always going to be this easy to identify. And you'll have some practice problems that we'll do in class that aren't necessarily challenging, but they're just a little different in identifying the rate of change. But all you need to remember is it's the difference of the y's over the difference of the x's. So the difference in the output over the difference of the input. Okay? And then now we're going to move into slope. So go ahead and take a little brain break if you need to before we move right along. And slope is actually one of my favorite things to do in math. Oh, it gets a purple smiley face. And the reason I like it so much is because it's very simple. And slope, let me give you the definition of it, is the ratio of change in the y values. Oh, well, hold on. Let me just type it for you. It'll be easier for you to see. Okay, so here's the definition of slope, and don't get concerned. We're going to make this a lot simpler. So let's read it. The ratio of the change in y values, rise, for a segment of the graph to the corresponding change in x values, or, I forgot to type this, run. Okay, now you're probably reading that going, huh? That doesn't make sense. And you're right. The math people who decided to make all the definitions for math decided that they were going to try to confuse you. I give you permission to cross this out with a highlighter. You'll still need to know the definition, but I'm going to make it a lot simpler for you. So my simple definition for slope is very easy. It's rise over run. And you still might be wondering, what in the world does rise over run mean? But after we do some examples right here, you'll get it really quickly and positive. All right, so let's say that I have the coordinate right here. I have 4, 2. And then I have this coordinate right here, 5, 4. Go ahead and mark those on your coordinate grid. And then take a line and draw the line straight through those coordinates and make sure that it goes through the coordinates. Okay, and then don't forget to add your extension lines, the little arrows that show that it goes on forever in both directions. Okay, so there we go. Your line should look just like this. And remember that I have a coordinate on 4, 2, and I have a coordinate on 5, 4. Okay. So that's a silly 4, but that's okay. So 4, 2, and 5, 4 are where I have my coordinates, okay? So all I'm going to do, you might want to grab a different color for this as well. I'm going to start on one of my coordinates, and it has to be, when you're finding the slope, you have to find what I call an exact coordinate. It has to be something that directly crosses exactly at one point. It can't just be somewhere like in the middle of a line. It has to be right at the intersection of two exact whole numbers or numbers that we can work with. So we're going to use these points that I already came up with, 4, 2, and 5, 4. We're going to start right here. And remember, slope, the definition is rise over run. And you are going to learn what that is right now, so listen up. Rise, we count how much we have to go up. Rising is up, or it's either going to be up or down. So rise, we have to figure out, we go up 1, 2 coordinates right here. So we've got a 2, and it's rise over run. So now we need to figure out what run is, and I'm going to do run in, let's do orange. And I have to run 1 time to get to this next coordinate. That's a perfect coordinate on my line. So I rose 2 and I ran 1. 2 over 1. Well, what does 2 over 1 simplify to? 2 over 1 reduces to 2. So the slope of my line is 2. Ta-da! Happy 2. That's our answer. That's it. And then what about this one? Let's do one from here, -5. And we'll do -2, +5 as one of our points, and then -5, 3. So let's do our coordinates. I'll write them over here in case you need them. -5, +3, and then -2, +5. Okay, so we have to get our line, draw your straight line. This is where a straight line is very helpful. And then you're looking for exact coordinates, coordinates that hit perfectly on one intersection, not that it crosses over like in the middle. You're looking for an exact intersection. Okay, so, and I already told you what 2 of those coordinates are right here, -5, 3 and -2, 5. Those hit perfectly on the intersection. So we're going to use those. And remember, we're just looking for rise over run. So we're going to start on this dot. I'm going to use a different color than blue. Blue didn't show up very good last time. We'll use red. We have to figure out how much we have to rise. 1, 2. We have to rise 2 to get on that same line as this one. So we're going to have the 2 in the top for our rise. Now we need to find the run. How far do we need to run to get to this point? We need to run 1, 2, 3 to get to that point. 2/3. Well, guess what? Can we reduce this at all? Nope. So 2/3 is our slope for this line. That's it. That's as much as we can do. So 2/3 is our slope. Now, both of these lines, if you notice, are moving up. They're moving up towards the sky. And their slopes are also positive. What if we have a line that's dropping down? What if we have a line that goes down this way? Well, what do you think the slope is going to be, positive or negative? If you said negative, you're correct. Ooh, negative does not like to show up here. Negative. Anyways, negative. There we go. So we're going to do one of those examples right now. And let's go ahead and use, the coordinate 0, 0 as one of our coordinates. And then let's use -2, +4 right here. So those will be our exact coordinates. I'll write them here for you. 0, 0. Always use 0, 0 if that's one of the perfect intersections. It just makes it easy. 0, 0, and -2, +4. All right, so these are your two. Now you need to draw your line. Go ahead and do that now. And extend it a little bit past and draw your extension arrows. They're probably not even called extension arrows. I'm just making that up. All right, so 0, 0, and then -2, 4. Well, you already know, here's one coordinate, here's another coordinate. So let's figure out how much we have to rise. For rise, this time I'm going to use dark blue. So we have to rise 1, 2, 3, 4. So we have to rise 4. That's going to be on top. And then how much do we have to run? Okay, now this time we're running, but are we running forward or are we running backwards? This time we're running backwards. We'll run backwards 1, 2. So when we run backwards, we have to have a negative in front of our number. So it changes it to -4 over -2. Well, can we reduce that? We can. So 4 divided by -2 is actually just -2. So -2 is our answer. It's our slope. Okay, and we could have also started here, and we could have done how much do we have to rise? Well, we can't rise to get to another point. We'd actually have to fall. So we'd go 1, 2, 3, 4. We fell 4. We fell -4. And then we'd have to run, and this time we're running in the positive direction. So then we run 2. It'd be -4 over 2, which still reduces to -2. So you're allowed to start at either point on your line, any perfect intersection you're allowed to start at, and either drop first or rise first, and then calculate if it's going to be a positive or negative slope. If you ever have a line going in this direction, like this pink line or this red line, you know that it's going to be a positive slope. But if you ever have something going down, it's going to be a negative slope. All right, so you are allowed to have negative slopes in your answer, and you're also allowed to have positive slopes. They're both totally okay. Now let's quickly look at this. And these questions, especially these two, I'm not expecting you to know the answers to. I want you to make a guess. See if you can figure out what they would have without looking it up on the internet. And then this one is, would a line with a slope of -3 be positive or a negative line? You should know that. And then this one is, use a graph to find the slope of a line with the coordinates 1, 2, and 2, 4. These are my perfect coordinates, so you should be able to figure that out. Just use a graph and graph 1, 2, and 2, 4, draw a line through it, and then count rise over run. See, isn't rise over run a lot easier than this part? I think so too. So go ahead and finish your practice problems for class, and then we have a lot of practice to do with this tomorrow in class. I will see you soon.